The All-Russian Research Institute for Optical and Physical Measurements is the National Metrology Institute responsible for the realization, maintenance and dissemination of the SI units in the field of optical radiation. The development activities of the Institute provide the measurement capabilities in areas such as space research, nuclear energetics, nanotechnology and healthcare. The Institute performs fundamental research and development of national measurement standards in the area of incoherent optical radiation. Most of these standards are based on the so-called black bodies as the standard sources of radiation, as well as on the precise radiation detectors, absolute radiometers operating both at room and cryogenic temperature. Created at the Institute, high-temperature black bodies with the working temperatures of up to 3,500 Kelvin have unique metrological characteristics. These are the best high-temperature black bodies in the world. A number of national measurement standards have been created at the Institute, including the primary standard of luminous intensity and luminous flux, and the standard radiometric facility for ground-high accuracy calibration of the Earth observation instruments. Without such a cosmic standard, it would be impossible for Russia to participate in global projects like the Global Earth Observation System of Systems, monitoring of terrestrial processes from space. The high-temperature black bodies created at the Institute are widely used by the National Metrological Institutes of a number of countries. Following the global trend of conversion from incandescent lamps to LED sources, the Institute created standard facilities for verification and calibration of single LEDs as well as LED lamps. The development of alternative energy sources and energy-saving systems based on the use of solar cells also depends on the accuracy of the measurement standards developed by the Institute. The participation of the Institute in international key comparisons, initiated by the International Bureau of Weights and Measures, plays a crucial role. These comparisons allowed the confirmation of the validity and high precision of the created measurement standards. All of this research and development has a wide practical application. The Institute provides measurement assurance related to UV radiation. Based on years of experience, the Institute's experts have created the primary measurement standards, as well as working measurement standards and measurement instruments that are to monitor compliance with sanitary rules and regulations of the following domestic processes: workplace illuminance, determination of harmful doses of UVC radiation, for example in tanning beds or surgeries, precise monitoring of light sources in museums and art galleries, including point sources such as LEDs. To monitor the light pulses, which can severely interfere with health and mental state, the Institute has developed special devices, pulse meters. Another one of the Institute's developments is a unique portable synchrotron, whose orbital radius is only 17 millimeters. The radiation temperature of the synchrotron radiation reaches 100,000 degrees. In the course of experiments conducted in collaboration with the Kirchthof Institute, a scientific problem was solved that until quite recently was thought impossible: registration of single electrons on the synchrotron orbit. This is an important step in redefining basic measurement units by using fundamental physical constants. the Institute develops new methods and measuring instruments for manufacturing promising nanotechnology products. Works actively on addressing the problems associated with the use of extreme UV radiation, as well as its characterization. Today, the extensiveness of the application of laser technologies defines the country's innovative level. The development of these technologies requires modern measurement assurance. The Institute is the country's leading centre in the field of laser radiation metrology. The scope of the practical application of the Institute's developments is very broad, from high-tech industries to profound scientific research, from modern healthcare technologies to the latest models of devices. An example is the global navigation system GLONASS, the exact characteristics of which are directly dependent on the accuracy of monitoring the laser radiation parameters in locating spacecraft. Precision instruments using laser guidance and location systems, new processing technologies such as nanotechnologies, welding and metal cutting technologies, medical, surgical and diagnostic lasers, fiber lasers, semiconductor lasers, and nanolasers used in electronics, they all need modern measurement assurance. A separate branch of laser subjects are low-intensity lasers and fiber-optic data transmission systems. For rapid development of the branch, it is necessary to provide measurement assurance for measuring the parameters of the systems. The traceability and accuracy of measurements determines the quality and technical parameters of the very systems, as well as their compliance with national standards. High-speed optical fiber communication and data transfer systems with optical spectrum multiplexing, transmitting over 40 gigabits of information per second, are becoming increasingly popular. Information is transmitted through multiple channels, from 4 to 128, each operating on its own wavelength and distanced at least 0.4 nanometers from one another. The measurement standards and precision monitoring systems developed by the Institute make possible the loss and error-free long-distance transmission of vast arrays of information. In the modern age of electronics, where much information is transmitted by electromagnetic waves, protection against electromagnetic pulse is an issue of national security, which is dealt with by the Institute. Generation of various electromagnetic pulses and the study of their impact on various objects makes unique knowledge and capabilities available to the researchers. The Institute maintains the primary national standards of the electric and magnetic field intensity pulse. The standards create pulses of a special form for calibration of measuring systems of electromagnetic waves, with an intensity amplitude of up to 500 kilovolts per meter and a build-up time of a few picoseconds. Studying the effects of electromagnetic pulse interaction with different objects is carried out in anechoic non-reflective chambers with generators of pulsed electromagnetic radiation lasting from 10 picoseconds to a few nanoseconds, created on the basis of horn, vibration and other antenna. Despite the small dimensions of emitters, the achieved pulse power reaches hundreds of megawatts. Field pulses are registered using unique patented strip sensors, whose response times are equal to a few picoseconds. The Institute also maintains the primary national measurement standard of the lightning discharge current impulse of up to 100 kA, which provides measurement assurance of testing and development of effective protection of technical objects, primarily planes, helicopters and other aircraft, against direct lightning strikes. For achievements of state importance, the laboratory staff were awarded the State Prize for developments in this area. The Institute has 19 talented doctors and 54 devoted candidates of sciences, which constantly work on the creation of measuring systems. Their biggest achievement to date is the modern national system of the primary measurement standards, recognized by the International Bureau of Weights and Measures and leading metrology institutes in Germany, the USA, France, Japan, Korea and China. The Institute is always open for cooperation.